In discussing product mix decisions with capacity constraints, we need to think back to some of the things that you guys have definitely seen in your lower level courses. Recall that we can calculate contribution margin, which is very important. Contribution margin is revenues minus variable cost. In other words, what we can sell the products for less the very specific cost that it takes to produce the item. And what is left over is that contribution margin, which aids us in completely covering our fixed costs in order to then contribute to the net income number. All right, so contribution margin is very important. Well, when we've got multiple products, of course, we have what is called the product mix. If we have, for example, two products and they are both in the same quantity, 50% is one product, 50% is the other product. Well, what if we have three products and one product is 60% of the mix and another one is 20 and the third one is 20? Or whatever number you want to come up with. It's always going to add up to 100% of our total sales. But again, we've got a mix. Well, what would management want to do? They would want to maximize the sales of the item with the highest contribution margin. That would be the smartest thing to do. But what if we are a company that has some type of limited capacity, some type of constraint on what we are able to produce? If we have a constraint, we have to take that calculation of contribution margin a step further and calculate contribution margin per limited resource, not just contribution margin per product, because we have got to be able to say what we want to use that limited capacity for. All right, so let's take a look at our info here. Of course, a product mix decision is what we're talking about, and the decision managers need to make a decision about which products to sell and in what quantities. We do have a decision rule for these. When we have a constraint, again, we're going to take it a step further and we're going to choose the product that produces the highest contribution margin per unit of the constraining resource, not the highest contribution margin per unit of the product. All right, so here's a data set. What would typically be done is if we didn't have a constraint, then we would just look at the contribution per margin per unit, right? 15 is much higher than 4. So you would think we would want to select product B. Excuse me. But in all reality, this particular company has a constraint, and that constraint is the number of machine hours they have available in a given time. All right, so our machine hours is the constraint. We only have so many machine hours available for use. So if product A takes half an hour to do and product B takes 3 hours to produce, then we need to use those numbers to calculate the contribution margin per machine hour. So what you guys need to do is take the contribution margin per unit in dollars and then divide those by the limited resource. And in our particular example here, we've got machine hours. So $4 divided by 0.5 is 8, and 15 divided by 3 is 5. And the result shows us that we would definitely want to choose product A because it contributes $3 more per machine hour than product B does. Okay, so for each hour we're running the machine, we are better off to produce product A. So, what about other limited resources? What if you are a retailer and you are trying to choose how to stock your shelves? Maybe you're going to look at this on square footage of shelf space instead of limited machine hours. Okay, so capacity constraint and contribution margin per limited resource is a very useful tool.